you can do that. Sodium potassium, if it gets very hot, you can also use metals. That's used in several solar concentrators, big industrial types. Small scale, I don't know. It transports the heat, and again, just like the oil, it's basically to make sure that you get the hot stuff from one place to the other. Exactly the same things as oil. Also in collectors, if you have the concentrator collector where the heat or the light hits upon, if you put a nice or molten metal in that, so sodium, potassium, lithium, indium, there's lots of metals that you can use actually. You make the heat load on whatever comes next more smoothed, because the metal conducts the heat very efficiently, so you get less variation. This is very interesting, and I guess this is the second part of the video, or this is the end of the first part. We go to the second part because the video is getting too long. Ammonia. Ammonia is NH3. It can split into N2 and H2, and that means that you basically have a chemical reaction which is heat assisted. It creates two gases which you can then use a catalyst to get back together, and you get the heat out again. So it's very efficient and easy way to use, and it's also known technology. It's not new. Dealing with ammonia, everybody can do it, and you can have a closed system. So you can have your solar dish, this 1.5 kilowatt dish, I think can use this technology. You have a tube with a tank, and it captures it has ammonia and the two gases in it under pressure, and you have a solar dish on one end, and you have a catalyst thing on the other end, and you just can use the heat wherever you want. Similar system, and these are two dissociation type uses of or heat assisted dissociation, as I would call it, type of chemical reactions that can be used in solar concentrators. This is sulfur trioxide, which is a strange molecule, not very common, and it splits just like ammonia into two parts, sulfur dioxide and oxygen. And these two gases, these are all three gases. In the ammonia case, there's a fluid and two gases, which makes it very easy to separate them from each other. In this case, there are three gases. And you can pipe these three gases in their mixture through a catalyst again and get the heat out at a certain point somewhere else. So, and this is of course more efficient than using oil or water or metal, because as long as it is transported, these gases and the ammonia, the nitrogen and the hydrogen, nothing happens to the energy that's stored in them, because these reactions are not spontaneous, and you need a catalyst. And here's one example of catalyst of a chemical reaction. I read about hydrogen peroxide, that is H2O2, which can be produced with a light assisted reaction. So you have a reactor where you have infrared light going into it, and it seems to be, or according to the patent about it, it's a more clean way to produce it for more distributed production. But a drawback would be that you would have a very big reactive area on some kind of. You need a catalyst. So what you would have is flat plate catalysts with a number of mirrors shining on them, and of course that doesn't really make you think about the dish concentrator. But who knows? There may be a very creative inventor who can turn this process, of which I'm not 100% sure that it is a closed system, but it seems to be, because there's a reversible reaction, and there's the production of this stuff. Maybe there is some creative inventor that can make that happen. So I hope this is interesting to you, and I hope you look into it. Heat is 75% of the energy you use, so if you get a solar concentrator in your garden and you you ask me to make it for you, or you help me make a standard solar concentrator that I'm working on, which will be very cheap, which will be absolutely competitive with what you are using now, by donating some dollars, then or maybe investing. That's what I'm going to look for. I'll be very happy.